Hello everyone. Let's start my introduction of the bumping the host on Android, a host-based IPv4 to IPv6 translation. My name is Yun Hui from China Mobile. Okay, let's introduce the China and China Mobile IPv6 status now. China government just released IPv4 and with IPv6 requirement last year. The government required the experimental commercial network should be set up by the 2013, and the large-scale commercial IPv6 network and realize IPv6 to IPv4 to and IPv6 network interconnection by 2014 and 2015. As the largest mobile network operator in the world, China Mobile has only 0.9% of global IPv4 address. So the IP address resource is very critical for China Mobile because they have lots of the subscribers on their networks. By now, more and more smartphones connect to the network. In China Mobile, SamNet now have 10 million iPhone online and 50 million TD-SCDMA 3G net mobile phone online now. So the network heavy is low and lower. China Mobile has two experimental networks in two provinces. One is the dual stack in Henan, and another is in Guangdong per IPv6 network. So China Mobile has now is considering smoothly transfer to IPv6 only network because there is some requirement. Before 3GPP-R8, mobile phone cannot active IPv4 and V6 PDP is together. So IPv4 application should work in IPv6 only network in a long time during the network translation from IPv4 to IPv6. This is a long period. So in China Mobile, the IPv6 pure network requirement is very is critical now, and I have to do lots of the trial in the network. Now, these are the dual stack. How to support so many legacy IPv4 apps in IPv6 only network is a problem. Now, Apple Store have 500,000 apps. Android market have 250,000 apps is using for the IPv4 network. But if China Mobile transfer to the next generation of IP network, IPv6, this application should work in the new network. And we have got a solution for this. Bump in the host, Net46 solution. This solution is, the key point is have a bump in the host. Let the host do Net46 translation. There actually has two solutions for this. One is BIS and another is BIA. Bump in the socket and bump in the API. But these two solutions required the dual stack internet access. So in that two solutions, BIS and BIA, both the IPv4 and v6 should connect to the network. So they require too many resources and don't have the capability or specific capability to support IPv6 only network. So we have combined and upgrade the BIS and the BIA to separate the IPv6 only network protocol and let the host do net46 translation. After that, the IPv6 network can talk with the IPv4 server in the network side. So the network side should have the net46 and the DNS46. No, the solution bumping in the host is a done deal in IETF. BIS obsoleted BIS and BIA in IETF. The main changes in BIS from the BIS and BIA is the following items. The firstly is BIS support IPv6 only network connections. The IPv6 address pool use private instead of the result IPv4 address. This is a reference to the RFC 1918. Extending the ENR and the address mapper to operate differently. The following will have a more detailed introduction for this. Adding an alternative way to implement the ENR. ENR is extension name reserver. We'll do the name reserver for the BIS solution. The standard terms instead of instrumental and information because the BIS and BIA are experimental and information RFC in the IETF no. The BIS is a standard track. Support reverse PTR requirement in the new solution. Bumping in the host internal, I will introduce the internal of BIS. BIS and BIA RFCs are essentially have the same in the host. It's a bump. The bump actually do the IPv4 and IPv6 translation. Combine and upgrade the BIS and the BIA is the solutions is essential. Build the net46 into the host. There are two implementation options. One is the API translation. Another is the IP stack translation. The BIS solution support IPv6 only network without the dual stack internet size. This diagram is show the connections. The BIS host do the IPv4 application will call in the system. So the BIS will do the net46 translation, and so the operating system will connect to using the new IPv6 address to connect to the IPv6 server and do the communication with the BIS translation. The components in the BIS. There are two implementation suggestions in this solution. One is BIA, similar. Another is BIS. the BIA is the API translation, and the BIS is a network layer IP stack translation. The components is ENR, extension name reserver, address mapper, and function mapper. We can please take a look at these two pictures. There's a difference is the implementation layer. The BIA is the API translator with the three components, and the BIS is a protocol translator in between the IPv4 and the IPv6. The BIA-based socket layer intercept API translation. In this solution, we suggest the BIA translation because it is more essential after the implementation. When the BIH detecting IPv4 socket API function calls from the IPv4 apps, the function mapper will intercept the function calls and invoke the IPv6 socket API functions. The functions is the following is listed. The functions will be translated, but not because different operating systems has different API or implementations. So this is just a demo. But there are also some new APIs in IPv6. We listed it here. The key function, also the most useful function is get host name, and is installed in IPv6 by the get address info. This will be used commonly in the translation. The BIS-based network layer translation. This is according to the IFC 614 file. Use this IFC reference translates the IPv4 IP address to IPv6, and also translates to the IPv6 to IPv4 address. There are maybe some a suggestion for the implementation is for performance improve. To avoid unnecessary fragment, the host IPv4 module should be configured with a small enough MTU, because IPv6 enabled link MTU is 20 bytes. The extension name reserver. Extension name reserver in the BIH returns the IPv4 app's name resolution request result. There are two cases. One is the BIA incept the guest host name inside by the get address info, because the current application using IPv4 use the get host by name because they don't know the get address info in the IPv6 socket API. So let's look at the example. During the application query get host by name with the IPv4 API, the extension name reserver will translate it to the get address info IPv6 API. The get address info API in IPv6 will do the name reserver and reply both IPv4 and IPv6 address. But there are some different case in after the get address info return value. One is the get address info return just IPv4 address. So in this case, the application is in IPv4 network. So the extension name reserver will get the host name return the real IPv4 address to the application, and so the application is worker in the IPv4 network. But in the case the get address info return only the IPv6 address. So the IPv4 application don't know the IPv6 address. In this case, the extension name reserver should synthesize a IPv4 address for the application, and then they will let the get host name return a synthesized IPv4 address to the application. But the BIH will use the IPv6 address to connect to the IPv6 network. So, during this translation, the IPv4 application can communicate with the IPv6 network or server. Another case is get address info return both IPv4 and IPv6 address. So in this case, the device can connect to both IPv4 and IPv6 network node. In this case, we don't need the BIH to do the IP translation, so we just return the IPv4 address to the application. So the application can work with it, this case in the just use the IPv4 address. With this translation, the device can support dual stack connection with the network in the third case, and use the BIH translation, IPv4 application can communicate with the IPv6 only network. This is the difference with the BIS and BIA originally implementation, because the original BIS and the BIA require the device connect to the IPv4 and the IPv6 network together. There another component is address mapper. The address mapper is used for the synthesize IPv4 and the real IPv6 mapping table, and another function is maintain a local IPv4 address pool. Because in this case, the extension reserver need to synthesize IPv4 address for IPv6 address. In this case, we don't know how to synthesize the IPv4 address. So the address mapper will do this for the extension reserver. In this implementation, we synthesize the IPv4 address based on the RFC 1918. Actually, the original BIA solution is use the public one. Maintain the IPv4 and IPv6 mapping we don't know how to translate the two IP stack. We should let the address mapper set up the the mapping table. Okay, the mapping table has three cases. Actually, has three cases. They are just list two because the second one has another case. Okay, the network response, just like the get address info response is the network response. If the network response IPv6 address in the case, the extension name reserver will synthesize IPv4 address. In this case, we should create a record of the map between IPv4 and IPv6. Another case is the get address info return both IPv4 and IPv6 address. The extension reserver will return the IPv4 address. So in this case, also create a mapping between the real IPv4 and IPv6 address. But in the case return both IPv4 and IPv6 address is another case, because if the IPv4 address return the network is excluded address like the like this one, 127.0.0.1. The extension is name reserver will synthesize IPv4 address too, because this address is cannot connect to the network using etcd2. We should use in this case we should use the IPv6 address and let the device connect to the IPv6 network. Okay, during the introduction, let's look at the BIH working flow. The IPv4 application gets the application call from the with the socket API, and the query IPv4 address for IPv6. But in this case, the network side is IPv6 only network. So the BIH will translate the IPv4 address to IPv6 and connect to the IPv6 network and return. But the IPv6 network return only the 4A records from the host 6. With this 4A record, the BIH should translate the 4A record to IPv4 address. In this case, he will call the address mapper to create a mapper record and translate the IPv6 address to IPv4 address, and then assign the IPv4 address to the socket API and return to the IPv4 application. So by this, the IPv4 application connect to IPv6 per network, and he will call the socket API application to do the communication. But every communication with the the host 6 network should do the API translation with the address mapper, and the address mapper and the extension name reserver will get the date or information from the IPv6 network and return to the IPv4 application. So visit the translation, and in this setup, the IPv4 application gets the information from host 6 IPv6 network. Another case, this one is different. Is the IPv4 application gets the address of IPv6, but all the translation is done in the network layer. You request the IPv4 package. The extension name reserver will translate the IPv4 package to IPv6 package. In the BIA-based is just translates the function, the socket function, like the get host name to get address info. In the BIS-based setup is the translation is in the network layer. The IPv4 IP package will be interpreted and set up with the IPv6 IP package, and use the IPv6 package communicate with the host 6, and re-intercept with the IPv6 result to IPv4 package and return to the IPv4 application. So the IPv4 application does look like there is a IPv4 server working on the network. Also, there is a question is how the IPv4 application talk with the IPv4 only server in a IPv6 only network. This is a little conflict, but there is a case to do this, because when a network operator sets up the IPv6 only network, there are lots of legacy IPv4 applications there, and lots of the service is based on the IPv4 only server. So in this case, just with the BIH, it cannot work in this case, because in the IPv6 only network can communicate with IPv4 only server. So in the server side or in the network side, should set up a net46 translator component or device. When the BIH host translate IPv4 application with the BIH to the IPv6, and so at the IPv6 will connect with the net64 component, and the net64 component can connect to the IPv4 server. In this case, the IPv4 server can provide service to the IPv4 only application. So after combine the BIH and the net46 can let the IPv4 application talk with the IPv4 only server in the IPv6 only network. Okay, let's review the development status of BIH. The BIH is IETF IF6 close to the publication. Is in the draft status now. Maybe I heard from maybe it will be published in the June this year. The BIH is developed and tested on the Linux kernel 2.6.3 series. And this solution has been successfully tested on the following device. This solution has been integrated into the OFON 2.0. OFON is an Android-based OS development by China Mobile. Using the OFON has produced the ZTE U900 product. And this device is tested in the China Mobile experimental network. Another is on the HTC G2 Android device. It is worked and also used for the experimental test. We also worked with Nokia on the MeeGo OS. The testing is on the N900 device. It is work and successfully tested, but we also found some little problem with the neighbor discovery on the MeeGo platform. This solution is implementation based on the Ubuntu. So it is work on the Ubuntu products, the Ubuntu system. And based on this solution, we also development ultra high definition media streaming device service device. This is like a set-top box, but this using the solution, the performance of the set-top box is very good and is passed the test. The BIH has been open sourced. We have open sourced to the code.google.com. You can access this address. And the BIH has currently is worked as a kernel module. It's integrated to the net IPv6 BIH. And the project maintainer is bih.cmcc@gmail.com. If you have any question, can connect with this mail. Okay. Do you have any questions about this?
Oh. Is the China Mobile right now is currently supporting IPv6?
We have an experimental network in 2 provinces. One is in Henan and another is in Guangdong. Guangdong is a very big subscriber province now. These 2 experimental network, one is a province big, so has lots of the consumer now. The solution, we have, okay, let's take into the, in China Mobile, now have these 2 experimental network. One is the dual stack, and another is pure IPv6 in Guangdong. Because as the report, the OPEX will be lower if you set up a pure IPv6 infrastructure. So maybe in the future, the IPv6 pure network will be set up in China Mobile. Hi.
You said the performance was good in the streaming service, but do you have any benchmarks of the overhead that you encountered? Or any comparison?
Yes, we have some benchmark, but I don't have no. If you want that, I can send an email to you, or we can communicate later. Any other questions? Okay. Oh.
Comment on when this is getting into the upstream Android project?
No, we are working on package the BIH solution and the kernel patch to try to upstream. Is working on that. If there are some support or some ideas about that, we can work together on that. We are very, very excited to upstream that to kernel. Okay, thank you.